Hi everyone, my name is Mathematician, and in this video we're going to talk about a fundamental inequality, the triangle inequality for the absolute value. And in previous videos we've talked about the absolute value in depth, what is the absolute value, equations with the absolute value, inequalities with the absolute value, and I encourage you to check them out if you haven't seen them already. In this video we're going to really dissect the triangle inequality, intuitively understand what it is, state it, and think about it very visually. And the triangle inequality is beautiful because it also reflects an important moral in life, that the journey is what matters, not the destination. And we're going to see that really shine through in this video. Okay, so let's first start by talking about a visual example to really highlight the triangle inequality and the moral I just talked about. Okay, so this is what we're going to talk about today, is the triangle inequality. So I want you to imagine that you're an ant on the number line and someone is giving you directions. Okay, so we draw the number line here, we put 0, and someone is telling you to go 5 units to the right and then 3 units to the right again. Okay, so they tell you to go 5 units to the right all the way here and then another 3 units to the right. So this is 5, this is 3. And we can sort of denote it by +5 and +3 to say that we are going to the right. If it were negative, we would be going to the left. Alright, so we have this picture here. Now this is the same as saying just go 8 units to the right. There's no difference there. Okay, so that's the first example. The second example is, imagine someone instead tells you to go 5 units to the right. Okay, so +5, 5 units to the right, but then to go 3 units to the left. Okay, so then to go 3 units to the left to land up here. So I'll write -3 because it's going to the left. Now where are you going to end up? You're going to end up at 2. Okay, so here you're going to end up at 2. Now this would be the same destination as if someone told you to go 2 units to the right from the beginning. But the journey would have been much different. In this case, the journey is 5 plus 3 units. Okay, so it's not just 2 units. If you go directly, it's 5 plus 3, which is 8 units. And this is essentially what the triangle inequality is going to tell us. It's going to tell us that going directly to the destination is always the fastest route than taking a detour, such as going beyond the destination and then coming back. Seems intuitively obvious, but it's what the inequality is unpacking. So let's write that down in the following way. So this is what the triangle inequality states. It states that the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y for all real numbers x and y. So this is a universal law for all real numbers x and y. For all real numbers x and y. Okay, and so this is what the triangle inequality states. Now if someone just shows this to you, it's perfectly normal to take some time to unpack what this actually says, because humans don't think in terms of this. Even though math gives off this illusion that people do, they don't. We think intuitively and then we compartmentalize them in mathematical notation, and that requires some mental associations. So let's explain what the triangle inequality is saying with this picture in mind. Okay, so what it's saying is that when you think about a journey, if someone tells you to go x units in one direction and y units in one direction, okay, they could be different directions, they could be the same direction, the total distance you will travel is going to be absolute value x plus absolute value y. Okay, so I'm going to actually put this down in a different color. So that's the total distance. I'm going to write this down in blue. So absolute value x plus absolute value y is total distance traveled. Okay, why is that? Well, if someone tells you to go y units to the left, so that's like a negative number, absolute value is going to make that positive and it's going to tell you the distance. So for example here, when someone says go 5 units to the right, okay, the distance is absolute value 5, which is just 5, but then if they tell you to go 3 units to the left, you're subtracting 3, but when you take the absolute value of -3, it's just 3. So the total distance traveled here is just going to be absolute value 5 plus absolute value -3, which is just going to be 5 plus 3, which is 8. Okay, that's the total distance. Okay, so that's point 1. Point 2 is, what is this absolute value x plus y? So this x plus y is going to be the final destination of your journey. Okay, it doesn't matter if x is positive, y is negative, or whatever, x plus y represents the final point. So for example, if x and y are both positive, you'll land up at x plus y. In the same way that if x is positive and y is negative, you'll also land up at x plus y. But here x plus y is going to be x minus some positive number because y is negative. Just like in this example here, 5 minus 3 is going to be 2, which is the final destination of where you're going to be. And if you take the absolute value of that, that's going to be the total distance you travel to the final destination. So even if, instead of minus 3, I had something like minus 7, and I landed up at negative 2, the journey to go from 0 to negative 2 would be 2 units. So you wouldn't just say it's 5 minus 7, which is negative 2, you would say it's the absolute value of negative 2. So the absolute value of x plus y represents that even if x plus y is negative, this is going to be the total distance to land up at x plus y. Okay, so absolute value of x plus y is distance of shortest path to x plus y, which is the direct path. Okay, any number, you take the absolute value of the number, that is the distance it takes to go from 0 to that number, whether it's negative or positive. So absolute value of x plus y is shortest distance. Okay, so therefore, to destination. Therefore, it's implicit when you consider all these in total, it's implicit that this inequality is going to be true. The shortest direct path is always going to be less than any indirect path where you're taking a detour. Okay, so I can even illustrate this. I'm just going to change this example slightly and just re-talk about the minus 2 I just said, just to really clarify that. So if, for example, here, suppose, so one point before I do that is if I had this example which I just was about to erase, but if I had this example here, then the triangle inequality is just an equality. Okay, the direct path is actually the same as the detoured path. Stopping over 5 when you're going to 8 is just the same as going directly to 8 in terms of distance. So here the absolute value of x plus y is the absolute value of 5 plus 3, which is the absolute value of 8. And the absolute value of x plus the absolute value of y is just 5 plus 3. So it should be generally apparent that if x and y have the same sign, so you're going in the same direction both times. If x and y are positive and you're going to the right both times, or if x and y are negative and you're going to the left both times, then the detoured path that goes first x and then y is the same length as going directly to x plus y. It's only when you have a clash of signs, like here, where there is an actual inequality that isn't an equality. Okay, so let's talk about one more example. I will highlight all these points as we go along, but let's talk about one more example here. So I'm just going to erase this and talk about the example I just referred to, which is, suppose you go 5 units to the right, and then you go minus 7 units to the left. Okay, so minus 7 units all the way to the left, so you'll go 5 minus 7, which is negative 2. What does the triangle inequality say here? So here the absolute value of x plus y is important because x plus y is a negative number. So the direct path that goes from 0 to negative 2, which is 0 to x plus y, has length absolute value of negative 2, which is 2. Okay, so here we're going to just draw that in blue as well. So here you're going to have absolute value of x plus y is going to be absolute value of negative 2, which is absolute value of x plus y in this example, and that's going to equal to 2. And on the other hand, absolute value x plus absolute value y is going to equal to the total distance you travel, which is 5, plus the absolute value of negative 7. So I'm going to say that this is going to equal to absolute value of 5 plus the absolute value of negative 7, which is going to equal to 5 plus 7, which is going to equal to 12. Okay, so I've just drawn that all here, but 12 is the total distance you travel here, 2 is the direct distance, and of course this is going to be, 2 is going to be less than 12. So absolute value of x plus y is less than or equal to, in this case it's also true to say it's less than or equal to the absolute value of x plus the absolute value of y. Okay, so these are all illustrations of the same idea. It's a general principle, and we have this triangle inequality. Okay, so we've talked about it. This is all there is to it. You know, there's nothing very fancy to it, but compartmentalized, it looks like this. And to summarize, there is a further addendum to the triangle inequality, which is when is it actually an equality. So you can be very precise. In math, you can really understand things very clearly. So here, for example, we can, I'm just going to erase this here. You can now say that, just going to erase this all off. You can write that equality holds. Okay, so equality holds. So absolute value of x plus y is less than or equal to absolute value x plus absolute value y. With equality, if x and y, if one way of saying this is the following: if either xy at least 0 or xy less than or equal to 0. So what this means is that if x and y are both positive, then the triangle inequality is an equation. If x and y are both negative, the triangle inequality is also an equation. And I've been very precise with the inequality here, because if x and y are both 0, or x is 0 or y is 0, it's also an equation. So in that case, you know, y is 0, you can just see that it's just absolute value x on both sides, for example. Okay, so this is true, and this is again intuitively clear from what we've seen. Okay, so how would you actually go about proving it though? Okay, so this is just an extra. So far if you've understood the triangle inequality, there's nothing much to say in terms of what it is. This is how you think about it. Okay, this is how we think about it when we see this kind of thing. This is how mathematicians think about it. But how do you actually prove, you know, that this is true? Like, how would you write out a rigorous proof? So as an extra, you know, if you're interested in this, and you don't have to know about mathematical proofs, I'll just talk a bit through how this looks like, how a proof would look like of the triangle inequality. Okay, so let's kind of write that here. Essentially, the ideas we've written or expressed already is the proof, once you sort of make it very clear. You know, so in math, when you write a proof, you want to be very clear and watertight about how you say it. And I'm just going to illustrate one way of proving this, which is doing a case-by-case analysis, just considering all possibilities. So case 1, so this is the proof. So I'm going to write this as the proof. And the proof, when you write it out, it reveals the ideas. But people come up with the ideas and then write out a proof, to be precise. So the proof is, so case 1 is xy is both at least 0. Okay? So we're assuming we're going to consider according to the signs of x and y. If x is positive, y is negative, x is positive, y is positive, x is negative, y is negative, x is negative, y is positive. I won't go through all of them. I'm just going to illustrate a couple of them that we've already seen. So let's consider the case xy is at least 0. So in this case, we want to show this, right? So think about what both sides are going to be. So the first thing is, if x and y are at least 0, then absolute value of x is equal to x and absolute value of y is equal to y. Right? Because the absolute value doesn't change anything if you're already a non-negative number. Furthermore, so we've got on the right hand side, we've got x plus y. On the left hand side, we have to ask little x plus y, what is that going to be? Right? What is little x plus little y? Well, or when I say little, I just mean x plus y. What is x plus y? Well, x plus y is just going to be a non-negative number as well. Right? Because x and y are non-negative, so then we just say that the absolute value of x plus y is also equal to x plus y. So therefore, in this case, the triangle inequality is literally an inequality. Absolute value of x plus y, it's literally an equality. It's going to equal to x plus y, which is equal to the absolute value of x plus the absolute value of y. So nothing to show. So that's no inequality. It's just an equation. That's a triangle inequality there. All good. Okay, that's number 1. Now number 2 is, we can consider case 2. We have 2 other cases. I'm only going to consider this one now, and I'm going to erase this actually, or maybe I'll keep it up. I'll keep it up and erase this part. Okay, so the equality part. Okay, so case 2 is going to be the following. So case 2 is x is at least 0 and y is less than or equal to 0, or y is less than 0. Okay, we've already considered the case y is at least 0. So now in this case, again, think about all the terms very carefully. Okay, that's how we come up with the proof. We think about what it's saying. You have the ideas, and now you're just writing it out very rigorously. The way I wrote it there, have stripped away all the intuition about distance, travel, journey, etc. But it is watertight. Someone can read and understand it. How you think about it is different. How you write it is different. This is the main thing, sometimes takes time when writing mathematical proofs, but to kind of go from one to the other. But here we just want to be very precise and straightforward, and that's the beauty of math. Nothing is opinion based. So again, what is the right hand side here? Well, absolute value of x is equal to x. Absolute value y is going to equal to negative y. And this is the key point, because y is negative. Why we have considered, why have we split up into these cases, x, y at least 0, x at least 0, y less than 0? Because the behavior changes of the absolute value depending on the sign. So here we know absolute value y is negative y. Okay, so because y is negative. And so the right hand side, absolute value x plus y, absolute value y, is equal to x minus y. Okay, that's what it's going to be. So that's the right hand side. What is the left hand side going to be? What is the absolute value of x plus y going to be? So we want to show it's less than or equal to this. So this is the point where we have to also consider cases according to x plus y to understand why the triangle inequality is true here. So let's think about this. So the absolute value of x plus y will of course depend on whether x plus y is positive or negative. So let's consider cases. I'm just going to erase this side of the board now. So erase this side. So we consider cases according to if x plus y is non-negative. So here you're sort of thinking that you're going x units to the right and then negative y units to the left. Y is negative, so instead of going y units to the right, you're going negative y units to the left. But you're landing up somewhere at least 0. So in this case, absolute value x plus y is going to be at least, so we can write this as absolute value x plus y is just going to equal to x plus y, because x plus y is at least 0. And in that case, the triangle inequality is basically saying that x plus y is less than or equal to x minus y. Okay? And this is definitely true because y is negative. That's the key point. Because since y is negative, adding y to something is always going to be smaller than subtracting y from something, which is going to make it larger because y is negative. So this is true. On the other hand, so I'm going to call this case A, case 2A if you like, and then case B is just going to be the case where x plus y is negative. So maybe I will put that a little bit below. So here we have the case that x plus y is negative. So this is case B, x plus y is negative. So in this case, the absolute value of x plus y is going to equal to the negative of x plus y. So again, the reason we are considering these cases is because we don't know what absolute value of x plus y is really, unless we know what x plus y is positive or x plus y is negative. So if we have this, then we know that absolute value of x plus y is negative x plus y, which is equal to negative x minus y. Okay, so negative x, negative y. And now the triangle inequality is telling us that negative x minus y is less than or equal to x minus y. And that is again true because this is the same, if you cancel negative y on both sides, this is the same as saying negative x is less than or equal to x, which is a fact because x is at least 0. In the same way that this inequality, if you cancel x from both sides, it's saying y is less than or equal to negative y, which is also a fact because y is negative. So in both cases, we've established the inequality is true, therefore it's true in general. Now I want to make a couple of points before ending this video. The first point is that this proof you can intuitively visualize, we sort of visualized it with the number line, this has kind of made it mathematically very precise. Okay, so now we've just written this out, you don't need any visualization, and this is the point about proofs. You want proofs to be not opinion based and completely to the point, completely concise, clear, and straightforward. And that's the beauty of math, that you can construct these kinds of arguments that we've done here. Of course, you have to keep on going and consider the case x less than 0, y at least 0, and x less than 0, y less than 0. But here's a cool way of doing that without repeating everything, is just say it's true by symmetry. Okay, so you can finalize the proof that the other cases follow by symmetry. And what do I mean by this? So the other cases follow by symmetry. And what do I mean by this is that you just swap x and y, right? X and y are interchangeable in the triangle inequality. If you look at that inequality, x and y are symmetric, so the case where y is at least 0 and x is negative is the same argument. You just take this whole argument and you swap x and y in it, and you get the argument for that case. And of course, the other case where x and y are less than 0, that case you do have to write out, I guess, but you can also sort of say it's very similar to the case x, y at least 0. You can just replace x and y by negative x and negative y, and you'll get the argument for that case as well. The absolute values you have to compute, but they're easy enough to compute. So that's the proof. Now there are some slick proofs. So if you are watching this video and it's the first time you're seeing this, or if you're watching this video and you know this stuff already, for example, and you know that there are some slick proofs of this fact, you can write some 1 or 2 line, very quick arguments to explain why this is true. I didn't do this in this video because this is meant to be an introduction, and the proof-based part of this is also meant to be an introduction as a bonus, just to give you a sense of what mathematical proofs look like. That beyond doubt we have proven the statement for all x and y. Okay, we have not every x and y you like, we have handled everything and solved it. But once you have an argument, there's also a process just like editing an essay where you can take your argument and you can find either ways of polishing it, or you can find some better argument that does it even quicker. And math develops like this. The first time someone thinks about something like this, they may come up with a lengthy argument. That's normal. That's how the human process works. But over decades, centuries, millennia, people slowly, very quickly, condense everything very, very much. And you can do this, with this argument. And a lot of math, you see in university, if you take like first year level university math, this took, a long, long time in human history. Calculus was discovered in the 16th and 17th centuries. But ultimately, well, maybe it was the 17th century. I might be misremembering there. But ultimately, the point is that once it's discovered, people then go on synthesizing it. And now it's just taught at university level in a semester. But that process is also a process in itself. Okay, so I hope you loved this video about the triangle inequality and it gave you an idea why it's true, which is the main thing I want you to take away. You can also think about the proof part if you like, if you're interested in that. But take away why it's true to get a complete sense of that. And if you have any questions, comments, feedback, I'd absolutely love to hear them. Please leave them down below in the comments. I'll read all of your comments and I'll do my best to reply to all of them. And it would also mean a lot to my goal of creating free accessible math education worldwide to inspire everyone to enjoy math, to learn math. If you like and subscribe to my videos. The best thing about YouTube is that everything is free. And I'm very happy that I'm able to deliver this free content in my own time, and I love doing so. It means a lot to me. And by liking and subscribing, you'll help disseminate my videos to other people who'll also be able to benefit from them. So that would mean a lot, and it's free to like and subscribe. It just takes a second. And you'd be updated on future videos that I do. And I do plan on uploading very regularly. I will upload very regularly, I should say that. So thank you so much. Hope you have a wonderful day. I wish you all the best wherever you are. I hope you have a wonderful day, evening, or night. And I'm super excited to see you in the next video.